In this video, we're going to look at 3 ways you can constrain planes using the A2Plus Workbench. We'll learn how to make planes coincident, parallel, or at an angle to each other. I'll be showing you how to use these constraints as I assemble a simple table. I'll just be using the default constraint parameters throughout this video, and we'll explore them further in an upcoming video. Let's get started. You should watch my introduction to the A2Plus Workbench if you haven't already done so, because I'm going to assume that you already have a basic understanding of how constraints affect the assembly. I have linked to that video in the top right corner. First, I'll show you how to use the plane coincident constraint. This constraint makes the 2 planes coincident to each other. I use this constraint most in my work because it closely matches my intended application in woodworking. That is, making 2 faces coincident so they can be glued together. I have placed the parts in random locations to help show the effect of the plane coincident constraint. You'll need to place 3 plane coincident constraints for each joint in the table. We'll start by constraining the first leg to the left-hand stretcher. The stretcher is the long piece of wood that joins the legs together. Select the wide face of the stretcher's tenon, then select the corresponding internal face of the mortise. I have switched to the top view so that you can see the effect of the constraint as it is placed. Click the Add Plane Coincident Constraint tool. You could set the offset parameter to move the planes away from each other if you wish. I'm not going to change the parameters of the constraint because I want them to be coincident. I'll show you how that works later in the video. Now accept the constraint to apply it. You can see that the side of the tenon is now coincident with the side of the mortise and it is no longer free. I'll constrain the top of the tenon next by selecting the top face of the tenon and the top face of the mortise. I've changed to the front view so that you can see the effects of the constraint as I apply it. Click on the Add Plane Coincident Constraint tool and accept the constraint. You can see that the top of the tenon is now coincident to the top of the mortise and the degrees of freedom have been reduced to 1. The last thing that I'm going to do to this joint is constrain the shoulder of the tenon to the face of the leg. This will fully constrain the joint. I'll select the shoulder of the tenon, then the face of the leg, and apply the constraint. You can see that the stretcher is fully constrained to the leg. That stretcher was pretty easy to constrain because it was already in the correct orientation. But what about the rails which are not in the right orientation? Well, let's find out. I'll repeat the same steps on the rail. I'll select the side of the tenon and the inside face of the mortise before applying the constraint. You can see that the rail is rotated to be in the correct orientation because the 2 faces I selected are now coincident to each other. You might not always be successful, and in that case, you could transform the rail into the correct orientation before you try and constrain it. The remaining constraints can be applied now that the rail has been rotated into the correct orientation. I have created a playlist which will teach you more about the A2Plus Workbench. I have linked the playlist in the card above and in the description below. The next constraint we're going to look at is the plane parallel constraint. The plane parallel constraint is used to make 2 planes parallel to each other. In this example, I'm going to make 2 table legs parallel to each other by selecting the 2 faces I want to be parallel. Remember to hold down the control key when you select the second face. Now click the Add Planes Parallel Constraint tool to make the planes parallel. Click the Accept button to accept the constraint. The 2 parts are now parallel to each other. I don't tend to use this constraint. Do you? Please let me know in the comments how and why you use it. I will finish constraining the leg using the plane coincident constraint. If you like what you are watching, please consider buying me a cup of coffee. Your donation will help improve the channel. Now I'll show you how to use the angled planes constraint. This is not a constraint that I use regularly in my work. Imagine for a moment a box with a hinged lid. You could use the angled planes constraint to represent the hinge without actually modeling the hinge. Select the top face of the left box side, then the bottom of the top. Now apply the angled planes constraint and set the angle to 25 degrees. The lid is now at a 25-degree angle relative to the sides of the box. I'll need to apply additional constraints to assemble the top the way that I want it and move it into position. I want the bottom left edge of the lid to be parallel to the top left edge of the left-hand side of the box. I can't do that with the plane constraint tools, so I'm going to use the Add Axis Coincident constraint to do that. This constraint will be the subject of another video, so keep an eye out for that one too. The top left edge of the box will be made coincident to the bottom left edge of the lid, and the lid will be moved into place. Now I'll use the plane coincident constraint to align the end of the lid with the side of the box. Select the right face of the lid and the outside face of the right side. Now click the Add Plane Coincident Constraint tool. I want the lid to overhang the sides by 5 mm. I will use the offset parameter to do this. Set the offset parameter to 5 mm and the lid will move that much. You can change the direction of the offset by clicking on the Flip Direction button. Unfortunately, you can't use an expression in the offset parameter. I think this might be a useful addition in a future update to the workbench. Now accept the constraint to apply it. Now that we've learned how to place constraints using planes, let's explore a problem that regularly bites me because I keep forgetting this simple rule. That rule is, the parts you are constraining must be fixed in place or have at least one constraint already applied. This second version of the assembly has no existing constraints, so I can show you what happens. Select the bottom face on both of the parts at the bottom of the model. Click the Add Planes Parallel Constraint tool. You get an error which didn't make sense to me for some time. Changing the constraint parameters has no effect either, and you're just left with cancelling the constraint. To add insult to injury, the delete button indicates that the constraint will be deleted, but this doesn't work. You have to do it manually. When I looked further into this problem, I found that the A2+ documentation clearly says that the first part added to the assembly is assumed to have a fixed position. It also says that you can fix another part in position using a property on the part, and then you can constrain it. So if you find that you cannot constrain two parts in an assembly with no existing constraints, then there are two ways that you can work around this. You can either make sure that you select the first part in the combo view, in this case table leg 001, as one of the parts being constrained. Or you can fix another part in place first and then constrain another part to it. I've already shown you how to apply a constraint to the first part listed in the combo view, so I'll show you how to fix a part before constraining it. Fixing a part so that constraints can be applied is a fairly straightforward process. Select the part in the combo view. Click on the fixed position entry in the Data tab and change its value to true. Now select the faces of the two parts and apply the plane parallel constraint. This time it will be applied successfully. I don't use this feature because the degrees of freedom labels don't show it as being fixed until a constraint is applied to the part. I discovered that you can have multiple fixed parts in your assembly. I haven't needed to fix one part, let alone multiple, so I don't really see the benefit of doing so. Please leave a comment below if you can think of a reason. If you like what you're watching, please consider buying me a cup of coffee. Your donation will help improve the channel. You can learn more about the A2+ Workbench in the playlist in the top right or in the description below. The parts used in this demonstration were created using the Part Design Workbench. You can learn more about the Part Design Workbench in the playlist in the bottom right and in the description below. I hope you found this video interesting. Thanks for watching, and I'll see you next time.